everybody. In this section, we're going to focus on data that has a linear correlation. We'll start with a scenario where a golf pro wants to investigate the relationship between the speed of a golf club swing and the distance that the golf ball will travel when hit. And here's the data she records. It's here in both table form and as a scatter plot or scatter diagram. You can see from the scatter plot that the dots roughly line up in a line, and in fact for this data the correlation coefficient R is 0.939, so there is a strong linear correlation. Now once it's been determined using the correlation coefficient that the explanatory and response variables have a linear relationship, it makes sense to find a linear equation that describes that relationship. So we're going to do this by selecting two data points and drawing a line between them. So we're going to just kind of eyeball this. So I want to draw a line that sort of goes through the bulk of the points, you know, that kind of looks like it's the line that they're clustered around. I'm going to pick, again, we're just eyeballing it here. I'm going to pick those 2 points and draw a line through them. Okay. Okay, so yeah, that looks okay. So I've again connected 2 dots to draw a line that, just eyeballing it, looks like it's kind of a line that you might think of these dots as clustering around. And now what I want is the equation for that line. So just let's recall from algebra that to write the equation of the line, if you know a point on the line, so x1, y1, and you know the slope, this is a formula you can use to get the equation for the line. Now we're going to need to compute the slope, and remember we have that rise over run formula, change in y over change in x. Okay, so what do I have for points on the line? Well, it looks like, what did I select here? This point is 105. Let me go back and look at the data. 105. Pick the lower of the two, so that y value there is 275. And what's this dot? That looks like it's 99. Can't tell exactly from the scatter diagram what the y value is there. So let's go back to the data chart. 99, 258. Okay, so 99, 258. Those are the 2 points that I'm using. So the slope here, m, will be, and let's think of this one, I guess, as x1, y1, and let's think of this one as x2, y2. Okay, so the slope y2 minus y1 is going to be 275 minus 258 over x2 minus x1. So x2 is 105 minus x1 is 99. So we get, that works out to 17 over 6, which is 2.8333. Okay, now for the equation of the line, again, we're going to use y minus y1 equals m times x minus x1. So let's see, there's my x1, y1. So I have y minus 258 equals the slope we computed, 2.8333, times x minus x1, and let's see, x1 is 99 again. So now what am I going to have? Y minus 258. I want to solve for y. So let's distribute the 2.833 into these parentheses. So I'll have 2.8333x minus, and then using a calculator, 2.8333 times 99 is 280.4967. And then finally adding 258 to both sides, we get, because again, I want to solve for y, I get 2.8333x minus, and if I add 258 to both sides, I get 22. So in other words, minus 280.4967 plus 258 is going to work out to be minus 22.4967. Okay, so that's the equation for this line that we kind of drew based on just eyeballing what would be a good line to draw to sort of describe the middle of the data points. Let's go ahead and use this linear equation, which by the way is called a model for the data. Let's use this linear equation we found to predict how far the golf ball would travel, in other words, a y value, if the club swing were 104 miles per hour, and that's an x value. So in other words, we're going to put into our equation x equals 104. Okay, so here we go. There's our equation. We're putting in 104 for x. So y would be 2.8333 times 104 minus 22.4967. And that works out to be, again, you'll use a calculator, 272.2 yards. So what did we just do here? Well, we don't have a data point. It wasn't measured how far the ball would travel when swing speed is 104. We can see that in our scatter diagram because there's no dot with x-coordinate 104. What we just found was the y-coordinate of the dot on the line we drew, and we determined that what the y-coordinate there was, oh, what did I just say? 272.2 yards. So we would predict that if we did a measurement of how far the ball traveled with this club swing speed, it would be in the vicinity of or roughly equal to that y value of 272.2 yards.